So my dear students, so very good evening. And now today we are going to discuss the new another phase diagram. So yesterday we completed the phase diagram of this water system, and this is a one component system we already seen in the last video, that is how this particular phases will change by varying with pressure and temperature. So this is a one component system. You need two variables, that is one is temperature and then one is pressure, and here we will get a three curves like this. This is a boiling point, freezing point, sublimation curve. So yesterday all this we discussed. Now we will discuss a new another phase diagram. This is the another phase diagram which is for the CO2. So this is also very simple another phase diagram, and this is a phase diagram for the this is CO2. CO2 which is also a one component system. This is also a one component system. Actually this is not there in your semester syllabus, but once you need to understand this also, because in IIT you will get this particular graph also. See here what is the difference between this particular curve and that H2O phase diagram. So the water which is having the phase diagram, what is the difference between these? So in case of water, the diagram which is like this. So we already seen the graph. So in case of water, the diagram is like this, and this is the triple point, and that is, you know, that this is 0.0075, and here which is 4.58 mmHg. So you know that this is the phase diagram for the water system, and you know that this is a gaseous phase, this is a liquid phase, and this is a solid phase. So you already seen in the last video, but now we will see this CO2. So I don't want to tell you much about this CO2 phase diagram, but you must understand one thing here. So here also there is a triple point here. So here also the triple point is here, and here the temperature which is minus 56.4 degrees Celsius, and here also same, which is 5.2 bar here. So here also this is also very very important. So here this particular graph indicate it is a triple point. It is exactly similar with the water. So what actually main difference between the water and the CO2? So what is the difference actually? What is the difference here? You may observe here. So you can understand here. What is the difference? Difference ఏంటి మరి? See here, what is the difference here? So you can easily understand here. Here the graph is like this. So see here. So see here, and this is our graph, and this is liquid, and this is a water system for the, so this is a phase diagram for the water system. Okay, and this is our phase diagram for the CO2. So what actually difference between these things? So you can see here, this is a boiling point curve. So this is a boiling point curve, and here this is a sublimation curve. This is the sublimation curve. What is this? This is a freezing point curve. This is a freezing point curve or melting point curve. So this curve is major difference is between the water and the CO2. So you can observe here the CO2, in case of CO2, the phase diagram in which this particular CO2 gas which is having the freezing point curve which is completely different with the water system. So what actually here, see here, here when you increase the pressure, so when you increase the pressure, so here let us take here pressure like this. So when you increase the pressure, so when you are increasing the pressure, see here the freezing point which is decreases here. That means here pressure is inversely relation with the freezing point. That is in case of water. So I already told you in the last video how why it is the freezing point, why the freezing point is decreasing here. I already told you in the last video. But now we can observe here. Here when you increase the pressure, what happens here? So see here. So when you increase the pressure, what happens here? So you can check here. So let us take here. So here 5.2 bar, which is the critical pressure, sorry, triple point pressure. Now let us increase the pressure. So like this, let us increase the pressure. So I am increasing the pressure up to 73.7. So what actually see here? The freezing point which is moved here. So freezing point ikkada varaku move ayindi. So that means here the freezing point which is increased here. So which is increased here, and a minus 56 nunchi, let us take it is minus 30 degrees. So see here the freezing point is increased here. That means the pressure which is directly relation with the freezing point. So but in case of water, this here the pressure is inversely relation with the freezing point. That is a major difference. So you must remember these things. So in case of boiling point, here this is the curve. So the boiling point curve is completely, there is no difference. So boiling point curve is, there is nothing much similar, nothing is different. It is almost exactly same. The pressure is directly relation with the boiling point. So అంటే boiling point కి direct relation ఉంటుంది in case of both the CO2 and also water. But the major difference is only this. The pressure is directly relation with the freezing point. Hence the curve is like this. But here in case of the curve which is like this, the major difference is like this. So this is a freezing point curve in the CO2 gas, and this is a freezing point curve in the water system. That is very very important. So idokate ardham cheskunnanu. So this is a CO2 phase diagram, and the triple point gurtunchukondi. Triple point will be the value which is minus 56.4, and here 5.2 bar, and here this is a solid phase, liquid phase, and gaseous phase. And the degrees of freedom here 2. Area kada nana, area degrees of freedom is 2, because F is equal to C minus P plus 2. How many number of components are there? This is a CO2, that is one component, minus phase. Ikkada only gaseous phase undi. So one phase here, plus 2. So 1 minus 1 0, plus 2, you will get degrees of freedom as 2 here. So here also degrees of freedom is 2, here also 2, here also 2. So that you already know that. And in case of area, so in case of curve, this curve, so here you are having 1, here also 1 degrees of freedom, here also 1 degrees of freedom. Why? That is F is equal to C minus P plus 2. That is number of components, which is one component, number of phases, and this each area. So in each area there is a equilibrium between the solid and liquid. Here this is a liquid with the gaseous phase, and here this is a solid with the gaseous phase. That means two phases will exist on this particular line. So that is 1 plus 2. Then 1 minus 2 plus 2. 2 cancel, you will get 1. So the degrees of freedom on this particular line, which is 1 at each curve. And this at this point, see, observe here at this triple point. So the at particular triple point, what is the triple point? So at triple point there will be existing three phases. So three phases means that is C minus P plus 2. So that is number of components 1, 3 phases, and plus 2. Then 1 minus 3, which is minus 2, plus 2, and total which is 0 here. That means degrees of freedom at this triple point which is 0. That is also exactly similar with the CO2, sorry, similar with the water system. So water system ki CO2 ki పెద్ద difference ఏం లేదు నాన్న. Only the freezing point curve is completely different. So దానికి reason ఏంటి అంటే the volume of solid in case of ice. So in case of water system లో specific గా volume of ice is greater than volume of water. So ఈ reason ఒక్క reason వలన, so when you increase the temperature, it is converted into liquid in case of water system. But here in case of CO2, it is converting into solid. So this is very very important. So you must understand only this curve. So once again I am saying, for the CO2 gas, the pressure which is directly relation with the freezing point, and the pressure is directly relation with the boiling point in case of CO2 gas. But in case of water system, that is pressure is inversely relation with the freezing point, and pressure is directly relation with the boiling point. This is in case of H2O, and this is in case of CO2. That you must understand here. So this is the phase diagram for the CO2 gas. So let us start with the two component system. So let us see this two component system also.